Hi, everyone, and welcome to our GitHub InFocus APAC second session. Today's session is building a frictionless application security program. Next slide, please. Your hosts for today are Shlomi and I. Shlomi is our application security executive. Shlomi Shaki joined GitHub 6 months ago to lead our application security space in region, and he's based in Sydney. Shlomi held various technical as well as business positions around both software development and security for the last 25 years. And my name is Faten Healy. I'm a senior solution engineer at GitHub based in Sydney as well. I've been at GitHub for a bit over 4 years. And in my previous life, you can say I was a developer, support engineer, QA tester, consultant, sales engineer, solution engineer, all of that. Next, please. Before we get started, I just have a couple of housekeeping notes for you. The first one is around the chat window. So you can see at the top right-hand side, you've got a chat window. So please feel free to get involved, say hi to us, tell us where you are joining us from, as well as I have my colleague, who's Adrian Lee. He's a senior solution engineer as well at GitHub, who will be monitoring the chat window for us. Next to the chat, you will see as well the polls. So the polls we'll have a couple of polls during the session. So we want to try to make it as interactive as possible. So once we have a poll, please make sure that you will cast your vote. And we've got a Q&A. So at that top right-hand corner, you've got the Q&A section, where you can post any questions that you've got for Shlomi and I, as well as Adrian will be helping us with the Q&A section. If you like what you see and you would like to deep dive into the content and you would like a requested demo, there's a big request a demo button at the top right-hand side where you can click it, and we will be in touch with you straight after. I just want to give a couple of tips so you can get the best viewing experience with us. First of all, make sure that you are joining us from a desktop using Chrome or Edge or Safari, so whatever browser you've got. If you are using Firefox, make sure that you've got the latest version. And if there's any problem or you can't see the streaming, maybe if you're on try to refresh the page. That might help. The first troubleshooting tip. The second one, if you're using VPN, try to disable VPN maybe and refresh your screen. Try to log off and then log back in using the link that you've got. And another one, that if you've got any other troubleshooting issues with the platform, we've got our moderator, Adrian, as well as the GoCast team, who will be more than happy to assist you. We've got the docs tab at the top right-hand side that will have some documentation to help you with troubleshooting. Let's have a great session, everyone. And now to the show. We've got building a frictionless application security program. I will pass it to Shlomi to get started. To you, Shlomi.
Thank you very much, Faten. I really appreciate it. And hi, everyone. Really excited to be here. And as Faten mentioned earlier, over the years, I worked both in software development and security in the different companies like Mercury and HP and Fortify. And I've seen a number of attempts to launching successful application programs. I've worked with some of the large banks and some smaller companies as well. And today, what we're going to do is we're going to explore how to build application security programs that have as little friction as possible. Because what we've seen is over the years and talking to customers, we've seen quite a lot of challenges that customers are facing when they're trying to build application security programs. And we'd like to share with you some of the most common ones. It's not all of them, but at least they're kind of the most common that we hear, and hopefully some tips as well that you could use potentially in your environment to try and streamline as much as possible your application security efforts. And we're aiming to have this session as a very interactive session. So we have, as Fatin said, the Q&A, and there's also going to be polls. And I'm really curious to see kind of what sort of questions are going to come up from the audience. So feel free to put your questions in there. Okay, so ultimately, when we're thinking about kind of application security, and when I started application security around 2009, there were only really a few companies that acknowledged that software security is an issue. In fact, a lot of them didn't even think about cybersecurity as an issue. And teams had to really get the executive buy-in to build application security programs. The vast majority focused mainly on educating the executives about what breaches could potentially happen, and also building the business case to be able to fuel their application security programs, many times starting with maybe testing one or two applications, getting some proof or evidence in the field, and then showing it and kind of showing that this is an issue not in one single team but across the board. Fast forward to today. The vast majority of organizations, at least that we talk to, already know the consequences of breaches. Maybe they might underestimate them a little bit, but they also have some risk management frameworks in place. They know what they need to do. There's some level of application security in place that exists. And when I speak to customers, it's very rare to come across people that don't do anything at all to secure stuff. Some might do more than others, but in most cases, people are doing at least some stuff, whether it is education or whether it is some code reviews, even manual, doing pen testing, et cetera, et cetera. So there's all kinds of activities that already happen. But if you look at kind of fast forwarding again from about 10 or 11 years ago, when you go into 2022, the job that we have hasn't become easier. We're building more code, and that means that we have a bigger attack surface, which ultimately gives the attackers, or in fact human errors, more opportunities and more entry points to the application. We also have much more interesting applications, and we connect to our business partners. And so that brings along also more complexity. And complexity, I guess, in the security world is the enemy of kind of good security. The more complex your environment is, the harder it is to protect it, and the harder it is to protect your environment. So ultimately, complexity makes the problem not only bigger, so you have a bigger attack surface, but it's also a lot harder to defend. And then finally, in almost every single organization, you're not starting applications from scratch. You're always going to inherit some level of code or some level of applications, and there's going to be existing technical debt. In some, it's much bigger than others. And so our job is becoming harder moving forward, and we need to make sure that not only do we protect the new code or the new applications that we create, but we also need to look sometimes backwards into all the existing infrastructure that is there today, because that might be the way, the entry point for attackers. So that is making all our jobs, both engineering and security, a lot harder to secure apps. And then on top of it, when you kind of look at the cybersecurity landscape, the fight itself became a lot harder. So if you think about it, we're really fighting an asymmetrical fight. The attackers really have a lot of advantages over us, but it's not all bad. We're going to get to kind of what we can do to maybe try and turn the tables around. But if you look kind of on the left corner or the red corner, we have the attackers, and the attackers have unlimited attempts at trying to get in to our organization. They can try as many times as they want. Sometimes we'll block them, but ultimately there's very little attribution and retribution to the attackers. Also, the attackers usually have some sort of a mission, whether it is monetizing the attacks or whether it is to cause particular harm or bring down the infrastructure. They have a particular mission all the time, and they need to complete the mission. It's not an ongoing marathon where you need to keep on defending yourself. They also usually have the coolest tools because, one, they have the skills and they have the tools to be able to build their own custom tools specifically to be able to exploit certain vulnerabilities or certain weaknesses in your environment. And then finally, the attackers only have to be right once. They only need one single opportunity to be able to get in and be able to either exfiltrate data or exploit the application or do something with it. And there's so many ways to get in. On the other hand, the defenders are really at a disadvantage in most cases. We work under pressure. We have a skill gap. Ultimately, many of the organization, you're actually hiring sometimes new people into the organization. You have to train them. They're not necessarily people that came in with the mentality of defending the organization. And then you still have to deal with the technical debt. And also, at the same time, the tooling that you might have might not be optimized to be able to defend the organization. And finally, and this is the most critical thing, is whilst the attackers have to be right once, the defenders have to be right every single time. And so that makes not only our job is becoming bigger and more complex, it's also to start with a lot harder to actually fight. It's not really stacked up correctly. One of the things, however, that makes it probably better for the defenders is speed of releasing stuff. So DevOps, and with basically being able to release and ship code much faster, that means that the landscape for the attackers changes all the time. In the cybersecurity world, it's called moving target defense, and that makes it a lot harder for attackers to be able to do reconnaissance and be able to exploit applications. And so being able to ship quickly, in fact, in some cases, the security teams sometimes resist to it, but in fact, that's actually a good thing, because it actually helps to basically thwart the attackers from planning and be able to attack you really quickly. But before we go in, I'd like to pass on to Faten to do the next poll, and I'm curious to see what the audience think about in terms of whose responsibility is it to protect the organization.
Okay, so we're gonna open the first poll. Thanks, Jomi, and I totally agree. Like sometimes if the security engineer or the defenders are 99% right, that one mistake is gonna be the one that's gonna be the highlight of what's going on with them. So the first poll for today is, whose responsibility is it to make sure that we are shipping secure code? Is it the APsec team? Is it the engineering team as the developers team? Or is it a shared responsibility between the APsec team and the engineering team, as like both of them? I'm gonna keep it open for maybe a minute and see how it goes. So far, we've got over 93% with both, as like it's a shared responsibility between the APsec team and the engineering team. And then now it's going a little bit lower, but we still at least 90% are saying that it's a shared responsibility, which I agree with personally. I will leave it open and we'll give the audience a couple of more seconds before we close the poll. What's your guess, Shlomi? Is it going to be over 90% for both, or some people are going to point fingers? It's your responsibility only.
Look, in theory, I think most people will answer both, but in practice, that's not always what actually happens. Many times, it either falls on kind of engineering or only on security. It depends a little bit about the organization, but I'm curious to see what the result is. Yeah,
sometimes in reality, it's not with the same as what's the ideal solution that we want, or the response, right? So far, we've got 87% as both. We've got around 4% for engineering and 8% for the APsec team. I was hoping that it's going to stay over 90% for both. But...
Cool. That's really cool. And by the way, we're going to explore some of those models, like who actually owns it. But I think, like in most cases, you cannot do it without the security team, but you can also not do it without the engineering team because they own the software. So ultimately, it's a collaborative effort. But the question is, I guess, who's accountable at the end of the day to make sure that we're safe to go into production? So when we look at kind of organizations,
sorry, just one second. I'm gonna close the poll. So if hopefully everybody had the chance to vote, I'm gonna close it, and the answer for now is around 87% for both, 7% for APsec and 5% for engineering team. And let's continue.
I wonder who chose just the APsec. It's probably engineers that decided that they're going to put it on the APsec teams. That's fine. Cool. So that actually is a great segue to the next section, which is kind of like what do we see? Okay, so when we go and talk to a lot of customers, we see all kinds of situations. Some of them are in much better places than others, but generally speaking, if I kind of create, if you will, 3 buckets of maturity, with excluding the ones that absolutely don't care about application security at all, and they're just creating maybe early stage startups where they need to just first of all create something that customers would love, or create business value. But if I look at kind of the ones that do care about, at least to some degree, care about application security, there's really 3 buckets that we kind of think about. The first bucket of customers that we meet and we talk to, both Faten and I, is the kind of the reactive mode. I see less and less of those at this stage. It was a lot more prevalent in 2009 when I started specifically in APsec. Today, most companies do a little bit more than that. But the first stage is when you do nothing around application security, and then you kind of go in and you say, hang on a second, we're creating all this code and we have now customers, and maybe we have financial data or customer data and we need to protect it. And there's some sort of question coming up from the board. Guys, is your application or environment secure? And someone might not even be a security person in the organization, again, depending on the size of it, asked it that question. And that we call it the kind of the security gate, the ad hoc security gate, where ultimately either the security team or IT comes up and says, okay, we need to be responsible for security ourselves, and we don't have the capability ourselves to do it. So generally speaking, we'll just hire some penetration testing company to either come in and hammer my application for about 2 or 3 days and find all the stuff that doesn't work, or do some code reviews. And sometimes the development team itself, the engineering team, says, you know what, we're building this application. We don't even have a security person in this company, but we're kind of, we know it's the right thing to do. So maybe we'll hire some, either some expert to tell us whether we're doing okay or not, because we're not security experts. And also maybe we'll apply a couple of tools, maybe static analysis or maybe some dynamic analysis or fuzzing, but it's done generally in an ad hoc way. And the challenge here is that, generally speaking, application security at that point in time is done typically after the fact. When I say after the fact, ideally not after a breach, but sometimes it's either leading into some sort of an audit, or maybe we need to ship code into maybe to a customer, and the customer is asking, hey guys, what have you done from a security point of view? Or maybe we do kind of an annual pen test. So that's the first stage. The second stage is the more well-defined security gate. And so kind of after we've done the first one, typically customers will say, well, hang on a second, we can't continue and just hire someone from the outside and come in once a year and tell us what's wrong. That doesn't make sense. It's kind of like almost testing that the car brakes work when you haven't actually put the brakes into the car in the first place. Of course, it's not going to work because there's no brakes. And so then we kind of go into a more well-defined, structured security gate. And then basically we hire a security team, ideally with application security background, or even create an application security team. And that application security team generally engages with engineering to do a number of things. One is to train around application security, to build some sort of governance and policies. There's all kinds of frameworks that generally speaking are being used. For example, if you're familiar with OWASP SAM, so the OWASP project have a very cool framework that is focusing around application security, and it's called OWASP SAM, so Security Assurance Maturity Model. It's been around probably for about 10 years, and it's been maintained by the OWASP community. but it gives you kind of a framework to what sort of steps should you do throughout the software development lifecycle. But typically when people are thinking about it, they'll start with, again, it's still a security gate. It's still an assurance function that comes, yes, it might come in a little bit earlier in the process, and maybe the security team will engage with the software development team a little bit earlier, but it's still done relatively late in this SDLC. And it's definitely not done in the stream of your software development, especially not in kind of in a DevOps, agile manner. And so that is kind of the second stage. And that, generally speaking, at least reduces the risk. But what it does do is it also adds a lot of friction, because the idea is to do more of that security testing. By doing that, you could potentially frustrate the engineering. The engineering might get a lot of results, and the results might come in different ways that are not in their focus. And also, usually a lot of complaints around false positives. We're getting a lot of results. We don't know what to do with it. And it's just too much noise. And it's good for about maybe half a year or 3 months. But we need to remember, again, unfortunately, as defenders, we don't have the opportunity or the luxury of doing it once. We have to think about it as a marathon. So we have to do something that is sustainable for the engineering team that they can continuously do. And that's, generally speaking, the breaking point of basically engineering and security team coming in and saying, look, we need to find a better way. There's no way we can come in at the last minute. And sometimes engineering will actually initiate it, and will basically try and get a more streamlined approach, where the idea is not to go in and create basically, or expect some sort of a magic dust, so security magic dust that can be sprinkled at the end of the project, but try and build security into the lifecycle, and ultimately shift left to be able to build it as part of your process and not as an afterthought. It's really, really important, and we see it quite often. So with that, I'd like to kind of see with the audience that we have here, what's the take? What do you guys think in terms of your organizations? Are you reactive? Are you proactive? Streamlined? Let's see what's the distribution.
And I'm opening the second poll. What's the approach to APsec in your organization? So is it reactive, proactive, or streamlined? Reactive, as we do like ad hoc pen testings and code reviews, or proactive, we have a proper APsec team that looks after security, or streamlined, as engineering builds in security into the developer life cycle. So far, it's between reactive and proactive. We've got kind of reactive for most of them, around 40%. Let's keep it open for a couple of more seconds. Yeah. Is that what you expected? Reactive?
Yeah, unfortunately, that's the case.
Yeah,
that's the I expected more proactive, and maybe some streamlined. I mean, it's hard. Application security is not easy. It's a difficult thing. So was expected.
In an ideal world, it will be like really streamlined with the development life cycle. But so far we've got like 45% as reactive, that's the truth. That's the situation that lots of companies are in at the moment today. And hopefully that will change in the near future.
Yeah, I think there's a lot of good things that are coming out today. I think it's we've had for about 10 years, I think, a lot of education. There's a lot more awareness now. So it's not all bad. There's a lot of awareness. There's a lot more education. Also, I think some of the tooling is getting more appropriate and fit for purpose to be able to do it quicker, where the first generation of tools that came out didn't. So what's have we closed the poll?
I will close it now. So I've got 42% reactive, 21% proactive, and around 35% streamlined. I'll close it for now. Nice. Thank you all for sharing with us. If you want to share more details about how you guys are doing it, please feel free to add it in the chat window as well.
Great. So if I get it right, I just want to repeat it. So we have 40% reactive, roughly about 40%,
Yeah,
roughly about 20% of
correct.
proactive, and then about 30 or
30.
35%, give or take, streamline.
Correct.
Okay, that's a cool distribution.
Yeah.
And again, it really depends, I think, on also the organization itself. If it's a startup software development, we just started now, it's a lot easier. Where if you're in a large bank, you will have to do something because of compliance. You can't do anything at all, but at the same time, you have to deal with so much technical debt, and sometimes that code is not even yours. You can't even do anything about it, even if you wanted to. So it's not an easy thing. So as I mentioned before, I think we kind of all figure out one way or another that even if you're in a reactive, you would like to generally move into more of a security by design or built in versus kind of after the fact. As I mentioned before, like the kind of the analogy is like a lot of times, let's throw it over the fence and expect the security team to come in with all kinds of magic stuff. That doesn't happen, especially now when a lot of the older controls, especially with architecture, maybe in the older days, we could bunch all our applications as a monolith behind kind of a data center and maybe put some sort of a web application firewalls. Not that it's probably the most secure, but at least it provides some level of protection. You could at least do that. But today, with service-oriented architectures, with APIs, with basically functions, serverless functions, there is no way to actually put all of that behind some sort of a perimeter. And so you really have to build it into the applications. And to do that, you have to build it into the process. There's no other way. There is actually another benefit, and I don't want to spend too much time on it, but this is something that probably many of you have seen. And it's not just, by the way, that model of cost per bug across the software lifecycle is not something that is unique to security. It applies to quality assurance as well. I mean, I've started my career in software testing and automation, and even then, kind of the model, maybe the numbers were different. I guess with inflation, maybe it went up a little bit, but it's the same model. Like the earlier you can catch it, the better it is. And so for software security, the challenge with that is that often the only time that you're going to know that you have an issue is either at the end when you have a pen test, or unfortunately, if you have a breach, and then the cost exponentially goes up. It's not even like close. But if you apply good practices for software development and software security, you have a chance to really demonstrate cost savings. Now, obviously, if you don't do security, it's the cheapest is to not do it at all until you get breached. But if you are going to make sure that you eliminate all the vulnerabilities, it's much better to do it earlier. It's cheaper, and you have less rework and less frustration as well. I personally have seen a couple of projects where we sat down, we did the pen test. Unfortunately, we had the results. The results were not great, and it came in the last minute. And then you're sitting down with the software team, basically the project team, the security team, and the external pen tester, and basically you have to give the bad news that you can't go to production tomorrow. And at the same time, not going to production is going to cost the business a couple of $1 million a day. And so you have to manage that risk and decide, do we take the risk or not? Where if you did it earlier, it'd be a lot cheaper. So with that, I wanted to cover some of the common challenges about software security. So we all agree that it's best to do software security in a streamlined way. The vast majority of you have said that both software security, the security team and software engineering has to come together to solve this problem. And we all agree that it's better to do it earlier. So the question is, what are the challenges that stop us from doing it earlier? So let's cover probably the top 4 that we've seen. And starting with number 1, common challenge number 1, engineering and APsec are siloed. That is the most common challenge that we hear. When I say siloed, it typically, if you think about it, engineering really have basically a mission to build up amazing applications and to ship them quickly to customers and ultimately innovate much quickly. Where security is actually the opposite. The security team tried to slow things down to make it more safe, not because they want to be the no department, but because they are considering the risk behind moving too fast. And so in a way, you have two teams that are thinking in two different ways, and they have two different opposing missions. Both of them are really important. It's kind of, again, it's kind of like the gas pedal and the brakes in the car. You need both of them to drive around the corners quickly, but it's just a question of what sort of balance. And it's really important also to have the right communication. Faten, I'm curious. You've worked with a lot of our customers over the years. What sort of experiences did you see? Is that something that customers really see?
As relationship and communication between engineering and security team, I've seen lots of different range of communication style, if you want to call it, but the most common one, and it's one of the traditional one, is that the security team will get involved when something happens. So that communication is very incident driven, and if either there's an incident and the security team is brought in to work on that, or it might be like scheduled every month to just go through what's going on in the company, and that communication might be done either via email or a long PDF that is shared with the whole engineering team, and it might be like something that not all the engineers or the developers will look into, and this will make these two teams work more and more in silos. One of the extreme use cases that I can share with you is one of the security teams where they had the scanning results and printing them on like a piece of paper and then bringing it to the developer team to share it with them. And that's an extreme one. It's not a common or standard communication, but I've seen that. And that wasn't long time ago, unfortunately. But yeah, true story.
Also as known as DevSec paper ops or something like this. Someone will need to come up with the right acronym for it. So this is really common, and I think it's just a breakdown of it's really that the different teams misunderstand the challenges that the other team has, and they're just not working in the aligned way. And so the most common ways that we heard, or things that customers that are more kind of in the streamline area have done, is they focused on, and this might sound like a good idea. It's easier said than done maybe, but aligning the goals and incentives for both security and engineering so that both of them have common goals and they work towards the same mission. And so if we're saying that security tries to slow things down and make it safe, and engineering tries to push things quickly and make things that are amazing to use and great functionality, if we can find a way to give both of them some elements of the goaling across the board, then what that will do is it will bring those two teams together, and it will not, I hate to say force, but it will give them an incentive to work together towards a common goal. So imagine the security team had a goal of, look, we have a project, the project deadline is whatever it is, let's say October. We bring you into our sprints, into our discussions, and you have a goal to, once you kind of attach to the project, your goal is also to help us get it out the door at that time. And if you do, then there's some sort of a bonus. I'm not sure. So that's for the security team. And likewise for the engineering team, if we get to a point where we can release the product, and we can show that we ultimately reduce or we eliminate any critical or high vulnerabilities from our code, or maybe we can reduce the vulnerability density, which is basically how many vulnerabilities do we have for every 1,000 line of code, then we have some level of measures and some level of incentives and goals that are common, and it brings those two teams together. The other thing that we hear probably the best teams do is they really focus on engagement. And it's really easy to get trapped into, I mentioned measures. I've had a really interesting conversation with one of the experts in APsec that I worked with before and in a number of organizations in Australia. And I asked him, hey, what do you think about measures? And he said, look, measures are good, like things like vulnerability density and fix rate, etc. They're important to measure. The problem is if you do that only, and you focus on that, people will find a way to game the system. So you really need to think about engaging together. So if application security team, if there is one, can engage with the software development team as early as possible, and help them build a threat model and help them understand what could go wrong, what could be the abuse cases, and how can we actually build frameworks that will help us build secure software from the first go. So instead of, for example, leaving it to the engineering team to figure out how do we do input validation and output encoding, if the APsec team engages super early and helps them build the frameworks that can help those developers make sure that they're using the right frameworks, that actually helps a lot. That is a big difference to a lot of organizations. And then finally, keep it simple. Try and focus only on the vulnerabilities that matters. Don't sweat the small stuff. There's going to be stuff like cross-site scripting, SQL injection. Amazingly, they are still a thing in 2022. And we need to focus on the stuff that literally can bring down your organization, and avoid focusing or boiling the ocean trying to fix everything, because you try and do that. First of all, you're going to get a lot of fatigue in the engineering team. And second of all, you're treading water. You're doing a lot of stuff that is meaningless. Plus, there potentially is different ways, different kind of compensating controls to protect from those vulnerabilities. So just because, take Spring, for example, the latest Spring vulnerability, that was only applicable to certain JRE in production. And so there are other ways that you can actually avoid fixing or changing the whole Java kind of the JDK that you're using. And so that is another way. So think about kind of what is the most critical, and work in a risk-based approach. Common challenge number 2, lack of expertise. And so if you were in engineering and you're thinking, oh my God, this is really hard to do application security, think about the lone application security engineer that you kind of have. And so there's different surveys that I've seen that measure how many application security engineers there are for how many software developers in an organization. But when we did the research, we looked at it and we kind of came up to roughly about 500 or 550 people per application security engineer. I've seen organizations with like 2,000 developers and having one application security engineer. Eventually they grew up, but it's outnumbered. Just for your knowledge, the best companies out there that do application security, and there is a couple of measures that do that look at the metrics. The metrics are for the most streamlined, probably most mature, I would call it like maturity 5, they usually have about 100 developers and 1 security engineer for each 100 developers. I'm not talking about engineers that have a security background and are basically the champion. I'm talking about an application security person that's the entire job is for them to do this. And so what that means is that you have a severe lack of expertise, because you can't just bring security people that have been building firewalls or doing network security and teach them application security. It just doesn't work. It's a completely different domain. So you need someone with an engineering background that have a mindset for security, and they are very difficult to come by, at least good ones. So that is difficult. And a lot of organizations struggle with it. And even if they can find the right people, very often those people either will get burnt or will move on to a different organization because they're going to get poached. So what can we do?
We're not trying to scare them here. We're not trying to scare all the application security engineers. It's just knowing that you've got like 570 developers who are writing code, adding new dependencies, doing all of the delivering new features, and doing all of that. And you're the one responsible to make sure all of the code that they're doing is safe is a bit scary. But the idea here to show that your work is very valuable and you want to be able to multiply it and make sure that you are like the most important person, that making sure all of these developers are writing safe code and secure code. We're not trying to scare any security engineer here. The opposite.
I think most application security engineers do it because they love it, not necessarily because it's probably the easiest job out there. But the approach needs to slightly change. So instead of basically, whilst application security has a function of assurance at the end of the process, I think the most successful ones that I've seen have taken almost like a force multiplier approach. They become the person that can then teach and enable security champions within the engineering team, find those people that do care about security, that have a bit of a spark, that have a bit of an interest to it, and not only train them, but help them kind of become the tier one or support for them, educating them, maybe creating even a team, an application security kind of extended team, and then doing monthly meetings just around application security, and then enabling them. And then those kind of people, those application security experts, are super, super valuable to an organization because they help the organization scale as opposed to just saying no. The other thing that is probably pretty obvious, but the more manual stuff you do, the more prone to human error you become. And so, and the more cumbersome it is. And so try and automate as much as possible where it makes sense. And when you tackle application security first, don't try and tackle the old technical debt, because that is going to be really difficult to do. Try and put automation to focus on eliminating new technical debt so that all the new stuff that you're creating is not going to have more holes in it. Like you're trying to make sure that you're creating buckets without new holes, as opposed to filling all the holes in the bucket that already exists. And then finally, with regards to education, I've seen a lot of organizations trying to do security education in general, and also developer security education. And there's probably the two different ways. There's the companies that do it from a compliance point of view. Hey, we need to just make sure that all our developers have been trained on how to write secure Java code or PHP or whatever it is, and it's once a year, and you ultimately click next, next, next. And at the end of the day, you get a certificate, and you finish that course, and you have no new knowledge at all of how to do secure coding. You're back to basically you're on your own. Versus, and by the way, in the last couple of years, or maybe more of the years, there's been actually quite interesting companies that create things like, or not companies, even projects that do more gamification. So at least to make it more interesting, but it's still a mass of knowledge that you need to learn at some point, but it's not specific to what you've done at that point in time. And so the thing that we see the most kind of effective on that side is make sure that if you design a developer education around secure software, make it relevant to a point where if you ran a scan and you found a vulnerability, let's say that vulnerability is whatever it is, let's say CSRF, then give the engineering a way to go and study, just kind of like a wiki, where they can click from the vulnerability and see what is that vulnerability, what's the cause of it, what's the different permutation in different kind of languages, ideally in the language that they actually scanned, and also what are really good ways to actually avoid it. So it's more education in time, based on actual results, based on the code that you write, not based on just theory. Because the theory, it's necessary, I guess, but it's boring, and it's not really conducive to really educating people. Next, so challenge number 3 is, even if you got into a streamline mode and you've got your security champions in place and you're engaging with them early and you have everything is happy days, unfortunately, 80 to 90% of your code is going to be open source. And so in security world, supply chain risk is one of the highest risks. It's kind of one of the biggest, hardest things at the moment. We all heard about Log4j, and I'm sure some of you have had to go through and find all the libraries that have Log4j. Do we even have it? What versions do we have? Where else does it exist? What can we do? Oh, wait a second, we can't even change something. It becomes difficult. So supply chain is really, really important. It's really hard. There is no easy ways around it, but the main things is if you can think about the libraries that you're going to bring on board beforehand, make sure that you kind of vet it, or there's at least a process to vet those libraries before you bring them into the code. And ideally, you go into projects that are a bit more reputable, but that's not 100% guarantee. But probably what most customers do in order to tackle that aspect is to be able to understand the dependencies in the code, know what you have ultimately. Easier said than done, but I think Faten can talk to you about what are some of the possibilities around this to try and tackle that. And the final challenge that I'm going to talk about is the tooling. And so up until now, I didn't really talk about at all about tooling. And in fact, I always think that tooling is kind of the last thing that you need to think about, even though we are a technology company. And you're most likely using our tools to ship software. But processing and people is really important. But processing people, again, without the right tools, it's not the right thing. I mean, you can drink soup with a fork, but it's probably not the most effective way to drink it. And so one of the things that that we've seen is that customers have a challenge around either having multiple tools, too many tools, or they have not enough tools, or they have the wrong tools. And either way, even if they have not enough tools, or even if they have a lot of tools, they often very disconnected, they're not integrated, they're not really giving you kind of the right process in place. Fanon, I'm curious, you work with a lot of our customers, so you see that day in, day out. What's your perspective on this?
Some of yeah, that's true. Some of them might have multiple tools in place, but the thing is that they might not be using them properly, or it might be that the security team only has access to these tools and they're not giving the developers any access to get the results straight away. So it might be that they're not in sync with the results that they're getting from these tools. Sometimes they might have one tool in place, but this tool is providing the developers with the feedback straight away while they're developing, and they might be picking up things way earlier. And that's back to the previous poll that you had around if it's reactive, proactive, or streamlined. And there was a couple of things in the chat about is GitHub vision around being proactive and hybrid between proactive and streamlined, which is exactly what we're trying to do. We're trying to get the developer involved in the security from the beginning, and while they're developing, they get the feedback the same way that they're getting the feedback from their CI tool or from other things that they're using within their development. But and the 23 minutes, it's so true, because when a developer is writing code, it's going to take them sometimes longer or sometimes less to be able to go back and focus on what they're doing. So it's really hard to interrupt them. So you want them to focus on what they're doing.
Correct. And by the way, the research that you can actually Google it by Gloria Mark. She's a professor in the Department of Informatics in University of California. Interesting article, not necessarily specifically about software security or just software development, but generally speaking, if you are doing something and someone comes in and interrupts you, you're going to take 23 minutes to get back into the routine and doing what kind of you did, get back into the focus. And so imagine you get all of a sudden different tools telling you different things, and then you have to go somewhere else. The best analogy that I like to use is the kind of the GPS. So if you're probably from the 90s, then you maybe didn't use it, but if you're earlier, then yes. we used to have those basically big maps of paper blocks that Faten reminded me earlier, where you were driving and you had to go and stop kind of on the side and look up the map and then decide where you want to go. And then at some point in the 90s or maybe 2000, really, we started getting GPSs on the phones, but you still needed either a holder. By the way, those holders on the cars, they never work anyway. So you have to find something to hold your GPS. And when you're driving, you need to figure out where the map is. So it's a much better thing than opening up the book and trying to find where you are or where you need to go. A GPS with a phone is a huge improvement, but it's still something that means that you have to take your eyes off the road when you're driving. And today, if you think about it, most modern cars, maybe the kind of the top of the ranges, come in with a HUD display, so that they show you the GPS coordinates and where you need to go and instructions and everything in front on your windscreen. So you don't have to take your eyes off the driving and you're just driving. And so that's kind of the same analogy. The future in application security, in my opinion, it has to be built in, and it cannot be disconnected from your flow. It has to be part of that process.
That's the same as having that GPS built in the car, which is like having your security tool, your code scanning built in with your development tooling, wherever the developers are using. And we're up to our next poll. So the question is, do you enable developers to run security scan autonomously? So let me open the poll, and I think it's open now. So it's either yes, the developers don't need to contact anyone and they are able to scan by themselves, or it's a no, and the APsec team needs to be involved and they need to send the scanning results back to the developers. So far, we've got yes, most of them as over 80%. I'll keep it for a couple of seconds before we finish it. What's your opinion? Is it the ideal word? Is it going to be a yes and a no? It's depending on the scenario.
I bet that the vast majority already do it. I mean, if you asked me the same question 10 years ago, it was almost 10%. Nowadays, there's all kinds of tools, not only GitHub, other tools that kind of enable developers to do the scanning. And frankly, again, you cannot afford to wait until the last minute just before you go live to do that scan. And so a lot of engineers say, you know what, we just need to build it in. We need to do it for ourselves so that we don't get surprise in the last minute. And by the way, we also care about the code that we write. We want to make sure that it's safe, that it's resilient, and we need to make sure that we do something. It might not be perfect, but hey, it's better than nothing. So there's a lot of open source tools in the OS community, and also commercial tools as well that have advanced quite a lot from 10 years ago.
So we've got around 81% as like, yes, developer can do it. And then around 18% who would like the APsec team to be involved. I'm going to close the poll for now. Thank you. It's 80-20% exactly now. I like it when it's 0-0.
The 80-20 rule. Okay, nice.
Yeah.
And I think, by the way, it's always important to include the application security team in the scan. The question is, how much of it can the engineers do on their own versus relying 100% on the APsec team? And I think given that we only have one engineer, security engineer, to 500 developers, give or take, you cannot be reliant. Like, they cannot be the bottleneck. There's just, the future is, the math is there. You cannot really keep them as the bottleneck for you. You have to be able to do it yourself. And both the tools and the processes have to get better at doing it to enable the engineers themselves to run the scans. Cool. So Faten, over to you.
Thank you. I thought that it was a great session talking about the common challenges and some of the tips and tricks. I thought I'll add 3 of the main tips that came to mind that are quick to configure, very simple, and then you can benefit from straight away. I'm sure that some of the audience might have even more security tips that they would like to share with us. So please feel free to add them to the chat window. But the ones that I wanted to highlight is the first one, enabling protected branches. So once you've got your repo, you can go ahead and under the settings, make sure that you've got protected branches enabled, where you can, for example, there's lots of different rules. One of them is making sure that at least you've got 1 or 2 code reviewers who will check your pull request before it gets merged into the main branch. The second one around Dependabot. We saw Shlomi spoke about how the modern application are using 80 to 90% of open source libraries. And as you know, GitHub is the home of open source. So making sure that you are using these open source libraries or projects in a secure way. It's very easy, very simple to make sure that you've got Dependabot alerts enabled at the organization level, as well as Dependabot security updates. So around Dependabot, it's going to tell you if there's any outdated library or package that you're using. So you will be able to update to the version that's not vulnerable. And Dependabot security update will create, it's a bot that will create a pull request for you that will help you, guide you to be able to get to the version that's not vulnerable. And the last one, enabling secret scanning. So secret scanning is enabled by, like on public repos, it's by default, but if you've got GitHub Advanced Security, enable secret scanning to make sure there's no secret, no tokens, no password, nothing like that stored in your repo. So these are my 3 quick tips that I wanted to share with you today. I know there's lots of other tips that some of you might share. I'm gonna add one as well to the chat window, which is one of our latest, recent blog posts around some tips to make sure on how to ship code securely. Okay, so
thank you.
I know that we're running a little bit. We still have 3 minutes. So
yeah, I just thought, why don't I finish up, and then there's probably one question that I'd like to. I know we answered, so we tried to answer all the questions that were there. If you feel like reaching out to us, we can. But there was one actually really interesting question that I'd like to do. But kind of as a key takeaway, really, if I summarize the whole discussion, there's a lot to take in, and feel free to listen to this again. But the 3 things that we'd like to focus on is, first of all, foster and think about an experience that gives the developers the ability to run security on their own, because there is no way for application security teams to do it on their own. It's just not going to happen. You don't have enough of them, and even if you did, it's going to be too slow. The second thing is, from an application security perspective, you have to, in a way, almost let go, engage with the developers, but let go and give the trust that and the autonomy that engineers will do the right thing, but also retain the capability to verify. So sort of a trust but verify model. And then the tools are important, but the process and the plan around it are super important. Even if you have the best tools, if you don't have the right process and the plan around it, and you don't know how to use it the right way, it's not going to help you. So you need to focus on all 3. Finally, one last thing I will say, one of the questions that came up is around Copilot. And so does GitHub Copilot have a plan around static application security? We cannot necessarily comment about what's going to happen or not, but I personally think that has a huge potential to not incrementally change application security testing, but completely turn it on its head. Like, imagine that you had someone sitting with you, kind of almost like an AI helper that helps you bridge the 570 engineers to one security expert and bridge that gap. That would make a massive difference to people that are writing code. So definitely something that I think would make a big difference. We can't comment on whether it's coming on or not, but you can imagine kind of like the potential here is huge.
Yeah, I agree as well. I think it's going to be, there's a big potential to help as well QL developers to write the queries, so they can get Copilot to help with that as well. Okay, so before we wrap today, I would like to Remind you, we've got another session happening tomorrow, overcoming common barriers to shipping code faster. The same time, 3 p.m. AEST. And I will be having Daniel Figuscio and Adrian joining me as well in the session tomorrow. So make sure that you join us tomorrow as well. Before we wrap as well, I would like to, if you can please take a minute or two to share with us your feedback. So you can scan this QR code, or you can as well use it. It's a very short survey that will take a minute or two to tell us about your experience today. The link is available in the chat window. Adrian just posted it, as well as in the docs tab at the top right-hand side. Thank you so much for joining us today, and hope you enjoyed the session as much as Shlomi and I did. Thank you. If you need any deep dive session, don't forget the request a demo button at the top right-hand side. Thanks, Shlomi. And thanks a lot, Adrian, as well, for monitoring the chat window.